Hi everybody, I hope you're all doing well. I am, so I can make you this short video about Dijkstra's algorithm. So what is this algorithm made for? It's made to know which is the shortest path between two vertices in a weighted graph. So what is a weighted graph? A weighted graph is a graph in which each edge has a number. Okay, this number represents could be, for example, the distance between the two vertices, or it can be the time that you need to go from S to A, for example. This 8 could be 8 kilometers, or maybe 8 minutes. We don't know for sure, but we know that it's longer than the path from S to C. Okay, because this one is 7 and the former one was 8. Okay, so it's okay for us, but the real question is, I want to start at the S vertex and I want to finish at the E vertex, E for end. And my question is, what is the shortest path between those two vertices? I could try again and again, and maybe I could find the shortest path, but it would take much time to know it just by trying. Okay, so we need a special algorithm to find the shortest path. So the name is Dijkstra's algorithm, and it can be presented with many different ways. The one I prefer is a table presentation. Okay, so you will draw a special table with one column per vertex. Okay, so you just have to count 1, 2, 3, 4, 5, 6, 7. We need 7 columns here. S, A, B, C, D, F, and E. Okay, I try to have the first one, the start here, and the end here at the end of the table, for sure. And Dijkstra's algorithm starts with a special number in every column, in each column. You always start with a 0 for the starting vertex, okay? And you will use the symbol of infinity for every other vertex here. Okay. So each step of this algorithm will be represented by a line in the table, okay? And in this line, you will rewrite, you will overline the vertex where you are with, for example, a color. Okay, so I start at the S vertex, so I will draw my 0 in red. Okay, that means I am, for the time being, I am at the vertex S. And here, at every step, I will compute the distance needed to go to every adjacent vertex. Okay, don't forget you have arrows here. That means, for example, you can't go back from A to S. Okay, you can find graphs, weighted graphs without arrows. So that means you will have to take care about this. Okay, but for the time being, there's no problem with the sense. Okay, so if I am at S, I can go to A or to C. And one special thing in the presentation is that when you wrote in a column in red, that means you won't go back to this column anymore. So you can erase the rest of the column here. My S was my starting vertex. I won't go back to S anymore, so I don't need this column anymore. Okay. So if I am at S, I can go to A, okay, and the distance will be 8. So here is what I write. I write my distance here, 8, and I will write in small the letter of the vertex where I come from. Okay, the last one. So I can go to A coming from S. Okay, and the distance will be 8. But I can't go to B. So every vertex which can't be reached will keep the symbol, the previous symbol. Okay, so for B, it's again the infinite symbol. For C, I can go to C from S, okay, with a distance of 7. So we'll write 7S. And I can't go to the other vertices, so I will rewrite the infinity symbol. Okay, so that's my second step. And at the end of every line, I will choose the smallest number to be my next vertex. So here is my next one. So I won't need the C column anymore. And here I will write my new line. Okay. So I am now at the C vertex. Okay. Where can I go? I can go to B. Okay. I can go to B with a distance of 2. Okay. But I have to count from the beginning. So if I am at C and I go to B, I have to add a distance of 2. But I already had a distance of 7. So the sum of the two distances is 9. So the number will be the distance from the start. Okay, but here I will write again the letter of the last vertex. So I came from C. So 9 is the total distance from the start, but here is the last vertex that I used. Okay. So if I am at C, I can go to B and I can go to F. I can go to F with a distance of 3. So my total distance will be 10 coming from C. Okay. And I can go to A, so I will keep my 8S. And I can go to D and E, so I will rewrite my infinity symbol. And that's the end of the line. Okay, and we'll have to deal with each line like this. So what is my smallest number here? I see that my smallest number is this one. So for this step, I will take this one. So now I am at the A vertex. I won't need it anymore. You will need someplace. Okay, so if I am at the A vertex, where can I go? I can go to D and I can go to B. So if I go to the D vertex, my total distance will be 12. Okay, 8 plus 4. But don't forget I was at the A vertex. And I can go to B. I can go to B with a distance of 3. So if I am now at A with the distance of 8, and I go to B with the distance of 3, my total number will be 11. So you can either mentally choose the shortest one, the smallest one. I already have 9 here. So I don't need the 11. The 11 will be higher. So I don't want it. I just want the smallest one at each time. That's every step. So you can, if I have a small advice to give to you, you should maybe write the two different numbers. So I have the 9C, or I can have, if I come from A, I can have 11A. And I choose the smallest one, so for me, the 11A won't exist anymore. I don't want it. And from A, I can't go to F. So I rewrite what I had, and I can't go to E, so I rewrite what I had here. Okay, and this is my line. My line is complete. And again, you know what to do now. I choose the smallest one, so now I am at the B vertex, but I am at the B vertex coming from C and not coming from A. So if I am at the B vertex, where can I go? I can go to D, I can go to F. Okay, let's go. I won't need B anymore. So now, I am at the B vertex, I want to go to D. The distance is 5. So if I have 9 plus 5, the total distance will be 14. 14. So for D, I have 12A or 14 coming from B, 14B. Okay. I can go to F with the distance of 4. So 9 plus 4 will be 13. But I already had a 10C or 13B. Okay, and from B I can't go to E, so E will keep the infinity symbol. Okay, so I will now erase the highest numbers. So I don't want this number and don't want this number either, so I will keep the two smallest numbers. And now I have to choose the smallest one. The smallest one is now 10C. So I won't need this column anymore here. And if I am at the F vertex, where can I go? I can go only to the E vertex. So the only thing I can do is 10 plus 5, and it will be 15 coming from F, and it's the only thing I can do. So that means here at D I have my 12A. And now I choose the smallest one. It's almost finished. Here. That means I am at the D vertex. Where can I go? I can go to F, but I won't go to F anymore. It's done. Okay, I'm sure that if I go from D to F, the distance will be higher than the distance that was there. Okay, so that's not what I want. I can't go to F anymore. So the only thing I can do now is coming from D to E. So I just have to take this number and to add 6. And here is the choice I have. I can either keep the 15F I had. Okay, I will rewrite this here. Here is my last line. So the previous one was 12A nothing 15F. Okay, here is my line. So here is the end of the table. I can either keep the 15F or I can add 12 plus 6. So that means 18 coming from D. And I choose again the smallest number, but that means I don't need this anymore. And this is my smallest number. Okay. And now it's finished. That means I know which is the shortest path. The shortest path, you will have to read your table from down to up. But that means the end is E. The shortest number is 15, but coming from F. That means at the end of the graph, this is the end of the graph, and my shortest number is when I come from F. That means the previous vertex was F. Okay, so now I will look at the F column, it was this one, and at the F column I take the red number. The shortest path to go to F was when I came from C. So that means before F, I have to come from C. Okay, and now I will look at the C. C, it was this one, I think. Yeah, it was this one. No, here. It was the C column. So the shortest path to go to C was the first one when you come from S. And it's finished. Okay, let's count again. You have a distance of 7, here you have a distance of 3, here you have a distance of 5. That means the total distance will be 15, but with this algorithm I'm sure that it was the shortest path. So this one, here. It was the shortest one.